two other options we looked at were on-site generation of sodium hypochlorite, or y'all probably know as bleach, or bulk storage of sodium hypochlorite. And as you can tell from this table, the annual operation and maintenance costs in that middle column, the least expensive alternative is chlorine gas. That's based pretty much solely on the chemical itself. It's cheaper to buy chlorine gas than it is to buy bleach. And then the OPCC opinion of probable construction costs, because the plant already uses chlorine gas, it's pretty intuitive that it's going to be cheaper to just make some modifications there than to install a new system.
So are these incremental costs for the first one, or just what we're currently spending?
These are conceptual. The first column, or the middle column, is conceptual annual costs, so what you're currently spending, and then the column on the right is just some minor improvements for the chlorine gas anyway. Some minor improvements.
Right, but I mean the middle column, only the top line is what we're actually doing.
Right. Yes, the two down below are alternatives to what you'd be doing now. All right, so part of the evaluation was creating an opinion of probable construction costs. I won't go through this line by line, but the modifications that we talked about on the site plan, these are itemized lines for each of those. So with construction, engineering, and construction administration fee, we come to a total of about $8.2 million.
And this gets us to meet some sort of mandate from the state or some sort of technical quality? What are we moving towards here?
Sure, good question. There are a number of regulatory items that you're not necessarily in conflict with, but this will help better quality. This will help create a better quality water and kind of get away from being close on some regulatory limits.
So it would position us better in the future to meet the requirements.
That's correct. You'd also be seeing the colorized water issue. We'd be addressing that. You'd have some taste and odor improvements.
Jason, give us some summary of the manganese.
Yeah, the manganese. Mr. Hahn, one of the biggest problems that y'all face is your taste and the color issues with the manganese coming into your system, and that's always a really hard one to work on. But the other thing is with your disinfection system right now, you are getting a lot of DVPs with your disinfection byproducts, and a lot of these improvements for adding the chemicals will reduce the DPPs that are being put out in the system to your constituents.
The chlorine gas deal, is there any chance in the future the government tries to wean us off of that?
I would say no. I might consult David on this. There are definitely some benefits to switching away from chlorine gas.
So every project we work on now, we're looking at alternative chlorine gas, because in general, the fire marshal will say you can't have chlorine gas in an area that will have off-site consequences. And so there's EPA regulations and risk assessments and vulnerability assessments and annual paperwork to keep up with it, kind of trying to get a focus of driving people away from it. Who knows where the current administration might take it? They are more likely to do it than the prior one, for sure, but it's still unpredictable. There has been discussions in the past about chlorine rail cars getting beefed up and putting more cost into the whole delivery of it, because this chlorine comes across the state in rail cars just wide open to everybody. And so there's always the potential that somebody gets a hold of that, and that then is put into ton containers in regional areas, and the ton containers then travel through your streets, by your houses, to the plant. And there's all these points of susceptibility, and of course the point when you got to connect the cylinder and disconnect the cylinder, that's where the risk of really releasing it is, because you're making connection and opening valves. Otherwise, it's pretty passive unless there's an accident or a forced event that somebody's trying to do something. There's nothing pending now. A few years ago in prior administrations, there were upgrades going to be required anything much more expensive, and it hasn't happened. So who knows? It's possible, but I would say it's more common that we switch away from chlorine gas to a liquid chlorine that has no off-site consequence, no risk of danger to the neighbors at all. That's getting to be more of a standard issue.
So what would be the risk to the neighbor? I mean, I have been knocked out by liquid chlorine gas many years ago.
Because the
So I
plant,
know for our workers, it's hazardous to
workers are the
breathe,
risk,
but
yeah. Because the plant's down in a low area, chlorine's heavy, so it takes a pretty good wind to spread it. But wherever the path is, and most safety protocols require that the wind directions be considered and off-site consequences be considered, and so that some of that stuff has already been defined in the safety procedures, so.
but it's not explosive. It would be somebody inhaling the danger of.
Yeah, the gas,
For the
2,000
liquid
pounds
or
of
the gas?
chlorine.
Are we talking about the liquid or the
No,
gas?
the gas.
The gas.
Liquid is no off-site consequence at all. It's like if you spilled bleach out of a gallon container you bought at the grocery store. So, you know.
A little higher concentration than
And
store-bought bleach, but
how many of these containers do we go through a year or a month or whatever?
you have two 1-ton cylinders that are online, and they're probably switched out every 20, 30 days, 2 weeks.
2.5 to 3 weeks.
Okay, so it's fairly often, yeah.
And we will say, to my knowledge, there has never been a chlorine gas leak issue at the plant. Is that correct?
We have safety protocols in place when receiving the cylinders or receiving the ton containers, storage of the ton containers, changing the ton containers. We have safety protocols that are in place to prevent a release.
How big are these things?
2,000 pounds.
I don't know.
Probably about 3 chairs worth, and about that big, and a
Propane
couple
tank.
feet in diameter.
So they're not
18-wheelers.
Like maybe a 250 pounds propane tank, like one of those. It's a little bit bigger than that, but that'd be a good size comparison.
So my concern was the safety, obviously, but is the government going to be, are we going to be looking back at this in 5 years or something? Okay.
Good question.
And so how hard is that to convert over if we stay with what we had for now and all of a sudden 5 years from now, in his example, we had to switch over? Is that changing out everything or a few valves?
It kind of depends with what option you go with. On-site generation involves a salt brine system, and you're essentially running electric current through it to create that bleach. Or with bulk storage, you're just getting bleach deliveries at about, so store-bought's about 5%, with bulk bleach, you're getting about 12.5%.
On-site, you also have to build a building, doesn't it have to be?
With on-site generation, yes, you have to build an air-conditioned building. With bulk bleach, you just need to have storage and then proper containment if there is a.
And that's why it's higher.
Right, yes, there's a considerable amount of equipment needed for the on-site generation. Good question, thank you. All right, so we covered this slide, construction plus engineering of $8.2 million. We'll move on to option 2, which is purchasing water from the city of Fort Worth. So the city of Fort Worth currently has a 10-inch cast iron pipe that connects to River Oaks distribution system. Because it's cast iron, they're looking at replacing that kind of regardless of what River Oaks does. And so they've offered to cover the cost, the theoretical cost, to switch that to about 10,000 feet of pipe from 10-inch cast iron to 10-inch like ductile iron. And so River Oaks would be responsible for upsizing, essentially upgrading from a theoretical 10-inch to a 16-inch. So you're kind of splitting the cost there. And so that's what that third column shows, River Oaks' responsibility of $2.8 million and Fort Worth's responsibility of about $3 million.
So that's the 2.7 is just the additional 6 inches added to the pipe?
That's correct. Some valves and air release valves, things like that.
And 707 is what we're currently paying them, so
Yes, based on current water rates from the city of Fort Worth, and an average